Hello everyone. In this video, we will see how to generate binary for an AUTOSAR project using AutoDesign Studio. We will first start with the description of the project which we will be creating. On the screen, you see a system consisting of two platforms, Raspberry Pi and STM32 board, connected using a LIN bus. The shown distributed system will allow balancing of an inverted pendulum platform. The link for the description of the inverted pendulum robotic platform and the STM board is provided in the video description. For the system shown in the figure, we will generate an AUTOSAR binary only for the Raspberry Pi, while the STM board will be executing bare metal code. For the Raspberry Pi, we will configure the communication modules including COM, PDU router and the LIN interface modules. Since LIN bus is designed for low bandwidth communication, we will only create single protocol data unit, aka PDU, to send the set point for the robot heading from the Pi board to the STM board, while the actual control system will be implemented on the STM board. So, let's get started with the project creation. First, we need to create a new project. Since creating a project from scratch will take a lot of time, in this video we will open a pre-configured project and highlight major project files and configuration parameters. In the project directory, my LIN example, we have some make files to help build the project. An AUTOSAR project file called linsample.arxml, a software component code file called tasks.c, a file defining task hooks called task_hooks.c, and an empty folder called config. The module configuration files will be generated in this config folder. Let's have a quick look at the tasks code. Here, we see that there exist two tasks, initializer and generator. The rest is an OS idle task, which is required by the ArcCore. As the name suggests, the initializer task initializes all the modules and makes sure that the board is ready to transmit the robot heading commands. The generator task uses an endless while loop to wait for an event which we intend to activate at each second. Notice that the first, fourth and fifth event activation, the task sends two COM signals, the speed signal and the turn signal, which are given different values at different activations. Now, let's have a look at the tool AutoDesign Studio. Here we will first open the ARXML project file. We see here that the BCM2835 is used as the mcal, and the output generation directory is defined as config. In the COM module, we see that we have two COM signals named speed_signal and turn_signal, both of 8 bits size. To send these signals we defined one COM IPDU with a name IPDU. To specify that these COM signals are combined in this IPDU, the two COM signals are referenced in the COM IPDU here. In the LIN interface module, there exists one frame called TX_frame with size of 2 bytes, one for each COM signal. This module also defines a scheduling table with 3 scheduling entries where the entry delay is specified as 3, 4 and 5 respectively. Moreover, this module also defines that this ECU is LIN master by this master entry. In the LIN mcal module, we see that the channel is configured with 9.6 kilo baud rate and uses the channel ID 0, which is mapped in the Raspberry Pi mcal to UART0. In the PDU router module, we see that a PDU routing path is defined with source as the COM module and the destination as the LIN interface module. In the OS module, we have two tasks, initializer and generator, similar to the C code file. Both of these tasks are set to auto-start by this auto-start entry. The module also defines an event called OS event, which is activated by the alarm OS alarm at the intervals of 1 second defined by the cycle time. Here, In order to avoid lengthy video, we skip showing the configuration of the rest of the modules. Now, we will generate the code for these modules by clicking this button. We see in the output window that all the modules are successfully validated and generated. Let's have a look at the config folder. In the config folder we see that the module files are generated for the configuration. Now we will build the project along with the AUTOSAR core. In the terminal we type the shown command, which specifies that we are using BCM as the board and mylin example as the project folder. Executing the command compiles all generated module files, AUTOSAR core and the software component code. After executing the command, we see that a binary image for the project is generated. We now copy the image file to the SD card of the Raspberry Pi and try to run the robotic platform.